So as you see, this is the pump you are going to run, right? Okay. So as you know, I think you already did it last time. Maybe you're already familiar with this, but let me still emphasize again on those components here. This is the pump here, okay, right? So this is suction flow. This is discharge, okay? So flow goes into the pump and leave the pump vertically. These are the two pressure gauges, right? Suction pressure, discharge pressure, okay? Now you know, based on the pressure difference divided by gamma, you should be able to calculate the pump head at a given flow rate, okay? Is that right? Okay, this is the electrical motor here. So there's a panel here. In this panel is to change RPM. Okay, change RPM. Last time, remember when we do the system curve measurement, we will set the valve the same, never touch it. We change this RPM to represent changing different pumps. Then you can measure the system curve, right? This is for measure RPM. Not measure RPM, set different RPMs. Okay, in here. Usually, what we do is on the panel we key in a percentage. If we key in 100%, that means it run at the full level. So it was the fastest RPM. Okay, then it goes down to 90%, 80%, 70%, 60%. Okay, so that's what we use to control. Okay, here, this is the valve we use to measure the pump curve. Remember, we changed the valve opening, okay, valve to control the flow rate, right? Okay, when we do the system curve, the valve is set fixed, and we change the RPM to change the flow rate, okay? So in this lab, okay, the other thing is flow meter, right? This is the panel I showed you, and this is the pressure gauge. You have a flow meter here. Where's the flow meter? Flow meter is here. This is the flow meter. Okay, so that's where you read the flow rates. So in this lab, okay, we are going to simulate two pumps. Okay, one slightly different to the other one. We try to simulate it. Okay, so but the goal is still to measure two pump curves, right, for the two similar pumps. Okay, it's very easy to simulate the two different pumps. Here you have actually the same pump. You can adjust the RPM. Okay, you can have RPM set. The first RPM is like maybe 90%. The second RPM is 60% for the speed. So then these are the two similar pumps. Okay, they should satisfy the affinity law for the relationship. Okay, so again, now you're measuring pump curves. Okay, you're measuring two pump curves. So pump curve is pump head versus flow rate, right? So how do you change the flow rate? Okay, when you measure pump curve, remember you change the flow rate through this, through the valve. Okay, through the valve. So you change, let's say, 6 different flow rates, 6 different valve openings. Okay, you can read the flow meter, the flow rate, and then you measure the pressure difference between those two pressure gauges. Okay, so you can produce two pump curves. Okay, but see, this is not the end of the story. Here, this lab, not only we need to produce two pump curves to compare, you actually need to verify the affinity law, the ratio. Okay, your goal is to verify the ratio. So what I said earlier is in a same system, this two pump, the performance should satisfy these 3 ratios at a same system. Okay, so in that sense, in the same valve opening, listen carefully, very important here, at the same valve opening, which representing a same system, you have to measure the performance pump head and the flow rate for the 2 different pumps. Okay, so in other words, you cannot like say, hey, I set the first pump 90% RPM. Then I go through 6 valve opening, measure the pump curve for the first pump. Then I set the 60% RPM for the second pump. Then I go through that valve opening again, so 1, 2, 3, 4, 5, 6. You can produce that 2 system curve, but you lose the opportunity to compare the ratio, because every time you open, there's no mark on the valve, right? You have set 6 different openings, do 6 different times. But next time when you do it, you actually forget where exactly the valve opening is. Okay, you cannot track back to the second time when you measure the second pump curve. You can't trace back to the original 6 opening for the first pump you measure. Okay, so this is manual, it's not digital, so you can. So then you cannot. If you measure like say separately 2 pump curves, then you cannot verify the affinity law. Affinity law only can be verified in the same system, same valve opening. So what the correct operation to do this lab is, sure, you will have 6 openings for the valves, okay? But every time you set in valve opening, the valve set 1, at the 1 condition, you measure the 2 different pumps at that opening. Okay, so in other words, when you set the valve opening, certain valve opening, then you go to the RPM panel, okay, set 90% for the first pump, read the flow rate, read the pressure gauge, then set the RPM to the second pump, then read the flow rate, and then read the pressure gauges. Now you have 2 sets of data, right? For 1 pump and for the other. Then you can compare the flow rate ratio. Okay, you can calculate the pump head ratio, and you can also calculate the power ratio between these 2 pumps. And this is the measured ratio, right? Measured ratio. Then you can compare to the theoretical ratio from the equation. Okay, the theoretical ratio, do you remember? What are they? They are only related to the RPM. So you have RPM 1, RPM 2, which you know, okay? So basically the ratio should be the flow rate ratio. This is a theoretical ratio here. These are the theoretical ratio. But you can directly measure the flow rates ratio for that certain opening. You can directly measure the HP ratios for that opening. You can directly measure the W ratios for that opening. So these are the measured ratio, okay? Directly measured ratio. And this 3 equations are the theoretical ratio. I want you to compare to see if the actual flow rate ratio, if the actual pump head ratio, and if the actual power ratio match the theoretical calculation, which is based on the RPM ratio. Okay, for all 6 openings of the valve. Okay, is that clear to everybody? Okay, so not only you need to produce the 2 pump curves, okay, for the 2 pumps, similar pumps, but also for each pair of points on the pump curve, you need to check the ratio, measure the ratio in the theoretical ratio. Okay, so that's the goal of this experiment, lab number 6. Okay, so this is a report requirement. Basically, I want you to plot the both pump curves and compare the ratios. Okay, so I guess that's the lab number 6. Okay, so let me know if you have any questions. Okay, so I will post this video. Okay, you can watch the video as if this is actual lab.